All right, in this module, I'm going to be talking about checking for corruption. I'm going to show it to you live in SQL Server Management Studio. I'm going to go corrupt a database with a hex editor and show you how things look to SQL Server. Then I'm going to explain how it happens in real life and the things that we need to do as database administrators to head that problem off. Then I'll finish up by talking about what you should do when you find it, keeping in mind that this is a class for fundamentals of database administration. It's not my mastering database administration class. We're still on the fundamentals here. So the things that I'll expect of you will be a little easier than what I would teach maybe in, say, the fundamental or in the mastering courses. Let's start by corrupting a database. Now, the way that I'm going to do it is I'm going to put a database or create a database, put some data in it, and then I'm going to take the database offline. The reason why I'm doing that is just to let SQL Server let go of the file. This isn't what usually causes corruption. You don't usually see people walking around in the database server with a hex editor manually changing SQL Server's data and log files. But it's just that in order to mimic it very quickly, that's the most reliable way to do it. Then I'm going to bring the database back up online again and show you what it looks like to end users. I will get to the real life's causes of corruption shortly. It's just that I want to give you a really simple demo first in order to show what causes it. So let's switch over to SQL Server 2019. So I've got SQL Server 2019 here, and I've got a pre-created demo script that I'm going to go walk through. I'm going to start by creating a database, just say create database 50 ways, and I'm going to go jump into it. Now, if you look over on the left-hand side on Object Explorer, it now shows that I have a 50 ways database. I'm going to go create a table to leave your lover, of course, because, whoops, no, not new query, to leave your lover, because that's, of course, what you would put in 50 ways. And then I'm going to insert not 50, but just 4 ways to go leave your lover. And now if I look over at the 50 ways database, there's a table inside of it called to leave your lover. And then I could select the top 1,000 rows out of it, and ta-da, we have at least a few rows inside of to leave your lover. Now, so far, so good. I've got a regular database that's working as expected, but now I want to cause corruption. So to cause corruption, I'm going to take the database offline. Now, you don't need to take the database offline in order to cause corruption. It's just that I want you to give you a really simple demo later in order to go reproduce this. Switch over to the master database and just kind of refresh our list here. Now it shows 50 ways and it's offline. Now let's make corruption happen. Now SQL Server's data and log files, they're just files. If I go in and I look where my SQL Server data and log files live, here's my data file and my log file. Here it shows a primary data file and a primary log file or transaction log file. These are just files, but it's not like you would right-click on it and open with Notepad. The stuff isn't going to make sense in terms of things like Notepad. When you have a binary file, you want to use a hex editor. And here I'm going to use the hex editor XVI32 because it's free and doesn't require any kind of installation. It's really easy to use. And you can kind of think of this as like Notepad for binary files. I'm going to say go open it. I'm going to open the file 50 ways. That's the one we just created for our database, and say open. Oh, and I forgot to open the hex editor as administrator because of Windows is so super secure. Make sure that nothing bad could ever happen to our stuff. Yeah, whatever. So now let's open the hex editor again and go point it at 50 ways. And at first glance, it looks like it might be protected or encrypted somehow, but it's not. If you just click search and then find, I'm going to look for, say, Stan, because Stan is one of the Jack, make a new plan, Stan. So I'm going to search for Stan and say, okay, and here it is. Here are the 50 ways that I inserted. Well, there were only 4. Now, just as a side note here, this should also set off alarm bells for you, because this is the way that your data and log files are stored on disk. People can go in and see things if you put in, say, for example, credit card numbers, social security numbers, addresses, phone numbers, etc. All that stuff is in the database unencrypted by default. It's up to you, dear database administrator, to go and encrypt this stuff. But so in here I've got, so slip out the back jack, make a new plan, Stan. Well, what happens if the thing on the database somehow got corrupted? What happens if storage had an accident? What happens if Windows had an accident? What happens if SQL Server had an accident? And then instead of saying Stan, it said flan, because why not? It's tasty. Now I can click Save and Close. Now my data is corrupt. Now I'm going to go back over to SQL Server, and I'm going to refresh this list. Now, as far as SQL Server knows, nothing has happened because SQL Server doesn't constantly patrol what's happening inside the files. Granted, you're not taking your databases offline. That's not what causes corruption. More on that in a minute. But I'm going to go bring it online. I'm going to right-click, and I'm going to say Tasks, Bring Online. SQL Server's like, okay, success. I wish he's a guy's voice for SQL Server because he's dumb and stubborn and he refuses to ask for directions. He's all, trust me, I got this. But so in here, we have success for whatever that's worth. So we have success, and if I go back and I refresh my database list, as far as SQL Server is concerned, everything's okay. Now, that's the first thing to stop and think about for a second. SQL Server, when it starts up a database, doesn't go through and check every row and every column. It can't. Don't worry, I don't have the Rona. I'm just an asthmatic, so I tend to cough a lot. So, not that asthmatics can't get coronavirus, but I've been tested again recently, so we're all good. Knock on wood. That's why I teach virtually, because I don't trust you people. You don't put on your masks. Wear your masks. So when SQL Server spins up this database, it's not like it does anything to go and check for corruption. SQL Server just goes and pulls a few pages up to make sure it can access system objects and says, everything's good, database is offline. Nobody's getting emails by default. That's something that's left up to you. Let's go see what's going on now. So now at first it looks like everything's okay. 50 ways looks okay. I can just expand this table. The table structure looks okay. As far as SQL Server is concerned, it's not offline or anything like that. The fun starts to pop up if I switch back into 50 ways again. Let's go switch over into the 50 ways database. And let's go run the select again and execute. Well, that's not good. Let's see here. What is SQL Server telling us? I detected a logical-based consistency I/O error. I got an incorrect checksum. Occurred during a read of database ID 9. Additional messages in the error log or operating system log may provide more detail. This is a serious error that threatens integrity. You should be correcting this immediately. Run a consistency check. This error can be caused by many factors. For more information, read the documentation. Nobody ever reads the documentation. Well, okay, this is really urgent, right? So now there must be some kind of red flag over here on my database list, right? No. And also, over here on the list of tables, everything also still looks okay. This is your next kind of big problem with corruption. When corruption strikes, SQL Server doesn't alert you by default. SQL Server doesn't send an email to you by default. SQL Server doesn't wave a red flag in Management Studio. I had a blog post I wrote one time where I showed the database list in Management Studio, and I said, all right, folks, you need to learn how to watch for signs of error. Here are things you should look for whenever your database is on fire. When database corruption is happening, here's what the database list looks like. When you have a performance problem, here's what the list looks like. When you haven't had any backups recently, here's what the list looks like. And it was a joke because Management Studio doesn't tell you any of those things. It's left to you, dear reader, to go figure out when these kinds of things are happening. So how do you find out? Well, one way is that you could sit around and wait for your end users to tell you, hey, I'm running queries and just my application fails out of nowhere. We seem to get weird error messages, and that would certainly work, but of course, by that point, it's way too late. Thankfully, one of the things that's kind of cool is that when SQL Server detects corruption, it makes a note for itself. Kind of leaves a trail behind, like, I'm not going there. Leaves a little trail behind, like a note left on a mirror when your partner leaves you, let's just say. So we can go check that mirror and go see what's going on. So right now there's nothing that shows up over here in 50 ways, but if I go out and I know to query select star from MSDB DBO suspect pages, don't be suspicious, don't be suspicious. Here, SQL Server at least makes a note over in a system table somewhere, but how are you supposed to know to check that? Nobody gets an email alert whenever these things pop into here by default. You could set up email alerts to do that, and we'll talk about how to do that. And this is right about now is the point where you're grabbing a pen and you're writing furiously, I must remember to go check MSDB suspect pages all the time. Ain't nobody got time for that. What you do instead is use a monitoring tool. And if you can't use a monitoring tool, because monitoring tools all have alerts built in to check, for example, whenever rows show up inside here, this tells me that database ID number 9, file number 1, page ID number 336 had an error on it. And we should probably go and correct that error. Well, you and I don't have time to go query for all of these. So what you do instead is you run things like SP Blitz. SP Blitz is my free open source health check that goes and checks across all kinds of places looking for problems. And one of the things that it'll warn you about is right there, database corruption is detected. Now, if you go and watch the training modules on SP Blitz, I talk about basically warnings between priority 1 and priority 50 are the things that will get you fired. You want to know about the things that are priority 1 through 50 and start working on correcting those. But you don't want to be sitting around the database server constantly hitting F5 on this, constantly executing SP Blitz, looking to see when database corruption happened. You need a faster way to go and detect that. And for that, let's go back over to the PowerPoint slide. So just a second here, and we'll switch back over to this. And switch here. So one of the things that's really heartbreaking about this is that you would think if a backup is going to run, if a backup is going to go back up all the pages inside your database, that a backup would tell you, hey buddy, you have corruption inside some of these pages. But they don't. Backups still work completely fine. Here I'm running a backup after that corruption happened, and it shows that the backup database successfully processed. Why? Well, because a backup is just shoving data pages out the pipe as fast as it possibly can. And by as fast as it possibly can, I mean it isn't going to take the time to go and examine every page to see whether or not it has good stuff on it or flan instead of stan. Same thing with restores. Restores, by default, also don't check for corruption. They will successfully tell you that a restore finished just fine, even when that database is chock full of nuts. Queries, anything that interprets the page, that is what goes in and tells you, hey buddy, we've got flan here when I was expecting stan. So what causes this stuff? And obviously, you're not going to worry about someone going into your database server with a hex editor, but the common things that cause corruption are, 1, storage bugs. Sometimes it's really crappy storage. Sometimes it's drivers that sit in between SQL Server and the storage, things that are intercepting writes. Think antivirus software, storage replication software, defragmentation software. Cloud servers with limited I/O bandwidth. I've written in the blog about a problem where if someone's doing a backup in a checkdb, ironically, they can cause corruption when they have hardly any bandwidth. You overwhelm that storage bandwidth and it causes SQL Server to fail over from one location to another. And finally, SQL Server bugs. I know. You, dear reader, assume that because SQL Server is a boxed product that it does not have bugs. And here comes the heartbreaking part. SQL Server does have a lot of bugs. SQL Server has bugs all the time. And they get fixed if you patch for them. But if you just go in and drop in a brand new version, even in the year 2020, even if you go and drop in a brand new version, you would think that SQL Server is nice and stable by now, having been out for a couple of decades, but let me show you a few bugs just in SQL Server 2019. Just in SQL Server 2019, The first cumulative update that came out, CU1, had a fix in it. Hey, it turns out, I don't know why I'm using Clippy's voice for Microsoft, although it does kind of make sense when I think about it. Hey, it turns out that if you had that brand new feature on accelerated database recovery, if all of a sudden you disabled it and there were aborted transactions going on, we kind of left some corruption behind. In the good old days, people would tell you don't implement SQL Server until Service Pack 1. I was never really a huge fan of that because I think even Service Pack 1 has bugs. These days, there are no service packs for 2017 and 2019, like we talk about in the patching module. And I don't know when it's safe to get in the water. Here's Cumulative Update 2. Cumulative Update 2, concurrent PFS updates in SQL Server 2019 may cause database corruption. And I'm linking to a blog post that I wrote about it because after Microsoft published Cumulative Update 2, all of a sudden they pulled this cumulative update notice, just this part of the cumulative update, they pulled that out. I don't know whether they decided that they didn't fix the problem or whether they were ashamed of the problem. But in either case, I don't really feel good about that either. The problems continue. Cumulative Update 5, as of this recording, just recently got published. Cumulative Update 5, when shrinking a database. I don't feel a whole lot of sorrow for people who experience this because you shouldn't usually be shrinking a database anyway. But shrinking a database, you can encounter a database consistency error. Confirm that you do not have any inconsistencies by executing checkdb after shrink operations. Okay, look. The people who know not to execute shrinkdb also know, or don't shrink their databases, they know to check for corruption. But the people who are crazy enough to run database shrinks, they're not savvy enough to check for corruption. This is preaching to the choir. This doesn't even make sense. These are 3 instances. SQL Server 2019 has had 5 CUs, and 3 of the 5 CUs have been fixing corruption bugs. So corruption happens all over the place, and we don't know when it strikes because it's not like storage is sitting around going, oh, hey, you know that mission critical database you cared about? Yeah, I just wrote some garbage in order to. Hey, you know that mission critical sales database? Yeah, I just wrote garbage over there as well. Storage doesn't tell us whenever it changes the files underneath us, and SQL Server doesn't tell us when it knowingly just corrupted something, because after all, it's a bug. So whenever any of these things happen, we have a time bomb. I need to minimize the amount of time between when the corruption happened and when we discover it. Because the closer those two things are, the more likely it is that I still have good backups and I can recover from it. So how do I spot it as quickly as practical, especially when SQL Server by default doesn't tell me anything about when corruption strikes? SQL Server doesn't know. What I have to do is I have to ask it to. I have to ask it to interpret the contents of a page, or I have to tell SQL Server to go check the entire database for corruption. Here are the 5 things that we're going to do in order to minimize or reduce the time span between the time when the corruption happens and the time when we discover it. And I'm going to talk through each one of those. So first off, a second ago, when I did a backup of a corrupt database, I had this option commented out. It's called checksums. What this means is that whenever SQL Server reads an 8K page out, reading it out for backups, as it's reading each 8K page, it will check the checksum on that page to make sure that the contents of that page actually match what it's supposed to be. Like in our case, making sure that it's Stan and not Flan. Here, when I put in that option, when I tell SQL Server, go ahead and check the backups, check the checksums as you read them, then SQL Server catches it and says, whoa, hold on, 50 ways had an error in this data file, so we're terminating the backups. Well, that's kind of good news and bad news. Because what that means is that now, when your backups fail, you gotta jump. You can't just go, oh, well, maybe we'll try it again and see what happens. No, you got to jump on a failed backup job and immediately get in there because you might have database corruption now. You can also check them on your restores. On the restore options, whenever I go restore a database, and you're probably thinking, well, Brent, I shouldn't have to restore a database very often. Well, what you can do is you can offload those restores to somewhere else to go check to make sure that your backups are good. The more important a database becomes, the more a business says, we're not allowed to lose any data, then the more we have to do implementations like this where we're actually restoring the database somewhere else to make sure that it's actually good. Here, I get another check. But both of these only work with native backups. Like I talk about in the backups big picture module, the 3 common ways of doing backups. This only works with native backups, not VSS snapshots. If you're using tools like Veeam, AppAware, or Aperture, those tools just take a snapshot of the entire VM and then start throwing it out to disk somewhere else. They don't know how to interpret the contents of SQL Server's 8K pages. By no means am I saying that you shouldn't use those. I do like those VSS backup software packages a lot. It's just that now the checking for corruption is going to be left up to you, and we'll talk about another way that you can do that. If you're doing maintenance plans in order to do, say, daily full backups or periodic log backups, what you want to do when you're editing your maintenance plan is you want to check this backup down here, perform checksum. And at the time when you do this, you also have to check continue on error. Because imagine that you've got 5 databases and the second one encounters corruption, you wouldn't immediately want your backups to stop. You would want your backups to continue going. And then that also brings in another risk that I'll talk about in another module. But you would want your backups to continue going so that they continue backing up the rest. Keep in mind, like what we saw a second ago here with my 50 ways backup, the instant that we added checksums, it started detecting the corruption problem. My backup stopped working. This is kind of a mixed blessing. In the prior example, when I did a backup without checksums, notice that there are 2 minus signs in front of checksums, the backup continued and actually worked. Then when I put in the checksum option, not quite so much. So that spots most of the corruption types whenever SQL Server or whenever the storage corrupted and the checksums don't match. But there are other types of corruption where SQL Server knows that it's writing bad data to disk, so to speak. It puts a checksum on there that matches the contents of whatever the crappy data are, like with those SQL Server bugs that we talked about earlier. To catch those, what we have to do is actually pop open every page, read every row, read every column, and even compare indexes against each other to make sure that all of the data matches. This is what DBCC checkdb does, but checkdb comes with a whole lot of drawbacks. CheckDB has to be run for every single database. Like I talk about in the backups module, anytime that you have something that needs to be run for every database, there's always a risk that someone's going to set it up to just run for a specific few databases, like they're going to check a few database names in a dropdown, and then they're not going to go back and check the rest of the databases as more databases are added over time. If you're going to do this, you really need to check all databases every time. And sometimes people will ask, well, why wouldn't I just do this every hour or every day? Because the larger that your databases become, the bigger the performance overhead is. I'll give you a great example from one of my clients. At one of my clients, they have over 40 terabytes of data on a single server. On a 40 terabyte database, when they start running CheckDB, it takes them 6 to 7 days in order to finish. Before I got involved with it, they literally had a job that said, while 1 equals 1, go run CheckDB. So their server was just continuously checking for corruption 24/7. The instant that one corruption job check would finish, the very next one would kick in and start again. I do have to do this. Now, the larger that my databases become, the more challenging it is. But this course, under fundamentals, we're aiming for all of your databases being around 100 gigs or less. So for 100 gigs or less, you could actually run DBCC CheckDB on every one of your databases at least once a week. And then here's what the output is going to look like. For example, I'm running dbcc checkdb 50 ways just on the one database with corruption. And that's kind of painful, because this isn't really meant for automated analysis. This is up to you to figure out which lines you need to go and focus on. And then it's going to come up with, in the event of database corruption, all kinds of terrible lines in here that you have to then go figure out how you're going to fix. In this case, checkdb finished with errors, which is the sad trombone noise when we know we got to leap in and do something about it. Now, I talked about it being really ugly and performance intensive, that it makes your server run really slow when it happens. So there are a few different options that you can do to minimize the impact. In here in the fundamentals class, I'm going to talk about the 3 most common parameters that you can use that give you the easiest time with it. So first off, no info messages. What no info messages does is it just gets rid of all this garbage output that you don't really care about. Okay. The longer that this list is, the harder it is to interpret afterwards. Because of course, when you're reading a log file, it's not like the bad problems are going to be color-coded in red. You're just going to get a big long list of no errors found. So no info messages I always want to use whenever I'm running checkdb, so that way I don't have to parse through big giant error logs. Second switch I can use is physical only. With physical only, this means every time you read an 8K page during checkdb, just check the checksums and that's it. Then go bail. This makes checkdb a much lighter weight operation, but it doesn't catch all of the errors. It's not like it's comparing each index to make sure that they all have the same contents. So this switch is a way to make checkdb run faster. This switch is a way to make checkdb run slower. I know what you're thinking. You're like, Brent, why would anyone want to make anything run slower? Here's the deal. Sometimes when Microsoft SQL Server comes out with a new version of SQL Server, they're like, it just runs faster. For example, in SQL Server 2016, they made all kinds of noise about SQL Server, it just runs faster. CheckDB runs quicker. And I'm like, oh, wow, oh, kind of cool. Tell me how you made CheckDB run faster. They're like, well, it checks less stuff now. Does that stuff, could it still possibly get corrupt? Yes. Oh, man. So if I'm going to take the care to run dbcc checkdb, I'm going to run it with extended logical checks, because what this does is it goes in and checks deeper and deeper things, like comparing indexed views and computed columns to make sure that they actually have the correct data in them, where there are known bugs, where those kinds of things can become corrupt. So how do I use all of these things together? So if I've got database servers with less than 500 gigs worth of stuff on them, here's the way that I tend to approach it. First, do daily backups, full backups with checksum turned on, so that way I'm getting a good clean backup of it every day. At less than 500 gigs, you should be able to pull this off every single night. Some of us might have been playing around with differential backups. Hold that thought, and we'll talk about that over in the mastering server tuner, mastering database administration class, where I'll start to go into 1 terabyte plus databases. But if you're under 500 gigs, daily full backups are pretty much a no-brainer. Then log backups based on the business's data loss goals, like we talk about over in the backup module. So typically that means doing log backups, say, every 5 minutes, every 15 minutes, or sometimes even every minute. Then if you're running a 9 to 5 business and it's got quiet evenings, like if you're running a dentist office or a construction company where you know that there are relatively few number of inserts, updates, and deletes happening after hours, then do a daily checkdb with extended logical checks. If it's less than 500 gigs worth of data, you should be able to accomplish this every day. And it's not writing a lot to the database. It's writing a lot to the database server, but not into the database itself. This should be doable every single day. On a 24/7 business where you've got less tolerance for slowdowns, that's when you want to only do the extended checks weekly, like say on Saturday nights. And then what happens when you actually find corruption? The URL to know is brentozar.com/go/corruption. I got so sick and tired of being called by people, usually strangers, not usually my clients. I get so sick and tired of getting calls and emails from strangers going, hey, I've got database corruption. What should I do now? And you know when those calls come in? They don't come in when I'm sober. They don't come in on Tuesday at 10 a.m. They come in at the worst possible times, like Friday at 10 p.m. And I'm like, you know what? At the end of the day, I'm already drunk. I can't take those calls. You don't want me working on a corrupt database server when I'm drunk. It just doesn't work out well. So why don't I just publish an entire checklist of exactly what I do as a database administrator when I find corruption? And I'm going to give you this short rundown in here. So first, turn off your backup delete jobs, because if you've got things that are, say, deleting databases or deleting backups that are older than 24 hours, you may suddenly need those now in order to recover. So that's always the first thing that I go do, just to make sure I have a good history of backups as much as I can possibly get. Number 2, query that suspect pages table that I showed you earlier in this session. The reason why I do that is I want to see how widespread the corruption is. Sometimes it's just in one database. Sometimes it's already spreading throughout the entire server. The earlier I know how bad it is, it helps me grab the server owners and shake them by the shoulder and go, you got to get out of this burning house now. Whereas if they think it's just one database, they might just try to skate along for a while, even though it's still a really bad idea. Number 3, alert the storage team. I don't want to blame the storage team. And I even give you an email you can copy paste in that URL. I don't want to blame the storage team. I just want to say, hey, heads up, y'all. In case anyone else complains that they're having storage problems, I'm experiencing database corruption over here on this server. It's probably not your fault. It's probably a SQL Server problem. I'm lying. But I'm just going to say, just so that you're aware, I have database corruption on the server. I may need to raise a red flag later. You don't have to jump on the call now if you don't want to, but just giving you the flag heads up. Number 4, alert the application owners and stakeholders. Hey, I've discovered corruption inside this database. From this point forward, any inserts, updates, and deletes, I just need to give you the heads up. I may not be able to recover them. So we may want to shut the applications down as quickly as possible. I give you an email for that too. Number 5, review the history of your backup and checkdb jobs. Maybe your checkdb jobs have been failing for weeks. I'll tell you a true story. So true story, the first thing that I go and do whenever I walk into any consulting engagement, the very first thing that I do is I go and run SP Blitz. That same health check issue that I talked about earlier, that same health check stored procedure that I talked about earlier, I go and run that, and one of the first things that pops up is, hey, you've got database corruption, just like we saw. So I go into this big downtown consulting firm, big giant firm, did all kinds of consulting for super fancy pants companies. And I didn't know that everyone at the company wore suits. I know, I probably should have asked that. But when I go into consulting, I come in usually in a polo shirt or maybe sometimes a t-shirt. I just come in a polo shirt and blue jeans. So I walk into this conference room. I open the door where I'd never met any of these people before. I open the door and there's this like 40-person long table and everyone's wearing suits. I'm like, oh, woohoo. I'm like, I'm probably in the wrong room. And I go to close the door and they're like, no, you're Brent Ozar. Come on in. And so I come in and I'm like, oh boy, this is going to be a rock and roll. And so they're explaining the problem and we go in, put the SQL Server up on a projector and we go run SP Blitz. And the first thing that pops out is, hey, you have database corruption. And they didn't take me very seriously because after all, I'm a local yokel consultant who doesn't seem to know very much. And I was wearing a t-shirt and blue jeans, and so of course I didn't look all that credible to people who were surrounding me in suits. And the head DBA is like, oh, that's got to be a bug in your script. We don't have database corruption here. I'm like, oh, you're probably right. See, I love to play Columbo. I love to play the dumb, bumbling detective who just doesn't know anything. So I'm like, oh, you're probably right. It probably is a bug in my script. I was like, so you know you don't have corruption because I'm sure y'all do checkdb on a regular basis. Senior DB, of course we do. So we've got checkdb running every single week. He goes in and opens up the agent job log. And I'm like, yeah, let's just look at the history. And in the history of their checking for corruption, going down the list of every time the job had ever run for the last 2 years, all of them had red X's right next to it. And me being Columbo. Oh, don't worry. I said, it's probably not corruption. It's probably just like some kind of error in a script or something. Why don't you open up that job and look a little closer at the history and go see what it has? And people are starting to sit up a little higher in their chairs now and looking around at each other. And they go and open up the history. And then they're like, oh my God, all of these show database corruption was detected. Why weren't we getting emails? And they go in and look at the job, and it was configured to email one person directly, and he left the company years ago. Well, me as just a bumbling local guy, hey, I don't know anything, me in a t-shirt and jeans, I turned to the group of database administrators at the table and I said, hey, you're clearly seniors, you know what you're doing. I said, y'all are comfortable recovering from corruption, right? And I was playing them right into a trap. And the senior DBA said, of course, yes, we're totally capable of doing that. I said, great. Well, I'm going to go ahead and leave because my contract actually said I was here for performance tuning. I don't want anything to do with corruption as bad as it is in your database. I'm sure you're in good hands. Bye. And I left and I walked out of there. The company went bankrupt later, but I'm like, I'm glad I didn't stick around because you probably wouldn't have paid my bill. So that's number 5, reviewing the history of your backup and checkdb jobs. Number 6, look for an easy fix. Check the output of dbcc checkdb and make sure that it's not just a single non-clustered index, for example. And then 7, fork your efforts into multiple teams. What you want to do is break out those efforts so that different teams can work on different recovery options at the same time. Because you're going to have one team go and restore the backups, another team trying to run checkdb on another server, another team opening a support call with Microsoft, another team forked off calling a corruption consultant. And I don't want you to think that I'm the one under number 5, that I'm selling my services. In that number 5, I actually give you a list of consultants that you should go and call. I'm not in that list. Because if things get really bad, you're going to need to recover your last clean full backup. The last one that doesn't have corruption. You're going to have to restore the last clean full backup and all the transaction logs since. I don't know about you, but very often throughout my career, before I started having to do this stuff professionally as like a consultant, very often inside my career, I was doing daily full backups and then only checking for corruption like once a week. And then we were doing log backups, but I would only keep 2 or 3 days worth of log backups inside. That my worst nightmare with that is that every Sunday my checkdb runs and it reports everything's okay. Monday nights full backup runs, Tuesday nights full backup runs, Wednesdays full backup runs, and then all of a sudden on Thursday we get corruption. Well, I don't know when the corruption hit. Even if I'm doing backups with checksums, if I hit a SQL Server bug where SQL Server knowingly wrote trash to data to disk, like those SQL Server 2019 bugs that we talked about here, the only safe way for me to recover is to go restore the last full backup from before the checkdb, not after, and then restore every single transaction log since, in the hope that the bug is only writing trash data pages and that it's not writing trash log records as well. That's why your checkdb frequency also dictates your log backup retention. If you're only doing checkdb once a week, then you need to keep clean transaction log backups going at least a week through of history. And if your sobriety and sickness history is anything like mine, you may want to keep a few more days than that. I'm usually a fan of, say, 10 to 14 days. So to recap what we talked about inside this module, corruption is going to happen to you at some point inside your career. To be ready and prepared for it, configure your backup jobs to do checksums so that they're checking data pages on the way out the door. Second, check for corruption as frequently as practical using no info messages and extended logical checks to give yourself as much safety checks as you can inside the database. Keep your log backups going all the way back to the last good, clean checkdb. For me, it's usually even further than that. Enable checksums on your older databases. The databases themselves have an option to write checksums to the data pages. In some rare cases, you'll see databases that were created long ago, like 10 years ago, or they were created with a really crappy creation script that turned off checksums. If you run SPBlitz, we warn you about that, and there's a URL to teach you how to enable those as well. And then configure alerts so that your SQL Server automatically emails you whenever corruption strikes. I'm going to talk about that in a separate module, but the script is over at brentozar.com/go/alert.